All right, folks, welcome to our second lecture on fractions. This is going to take everything that we went over in fractions part 1 and add on it, quite literally. There are some things that you should be very familiar with after the last lecture. These are things you absolutely need to know going into this lecture. You should know what is a proper fraction, what is an improper fraction, what is a mixed number. You should be able to identify those immediately. How do you go from a mixed number into an improper fraction and vice versa? How then do you turn that improper fraction back into a mixed number? You should know what is an equivalent fraction. And then along with that, how do you reduce a fraction and how do you know when that fraction has been completely reduced? All of these are things you should be comfortable with. If you are not, please come see me and we can spend some time going over them. So let's go over our 4 basic functions with fractions. We're going to look first at multiplication because I think it's the simplest of the 4. So first step for multiplication, maybe the most important, if you have any mixed numbers, they need to be improper fractions. I think I mentioned this a couple of times in the math lecture, in the fractions part 1 lecture, that all mixed numbers will always have to be improper fractions for multiplying and dividing. And this is one of the reasons why you need to know how to convert to improper fractions. And then from there, multiplication is pretty easy. You just multiply your denominators together, multiply your numerators together. So here's our example right here, 2/3 times 4/5. 2 times 4 is 8, 3 times 5 is 15. Your answer is 8/15. That's it. It doesn't get much more straightforward than that. So 8/15, and then once you're done, this is kind of the undoing of your first step. Make sure that you finish your answer. I had a class once that would talk about this, like it's like putting the Instagram filter on your picture. Now you need to make sure your answer is pretty. So you need to ask yourself 2 things once you're done with your problem. Is your answer improper? If so, you need to make it a mixed number. If it's not improper, can you reduce your answer? If so, make sure that you reduce your answer. So 8/15 here, it's not improper. This is a proper fraction. Can we reduce 8/15? Well, the only things that'll go into 8 are 2 and 4 and 8, and the only things that'll go into 15 are 3 and 5 and 15, so we can't reduce this number. So that's it. We're done with that problem. Let's look at a couple more examples. How about this one? 4 and 1/4 times 5 and 2/3. So we have 2 mixed numbers. Very first thing we have to do is make these guys improper fractions. Unfortunately, we can't simply multiply our whole numbers and multiply our fractions and then call it good. So we have to turn them into improper fractions. So remember how we do that, our denominator times our numerator plus our denominator times our whole number, plus our numerator, which is 17 all over the denominator. Same thing here, 3 times 5 is 15 plus 2 is 17. So now that we have our fractions improper, we can multiply them. 17 times 17 is 289, 4 times 3 is 12. So now that we've multiplied, make sure that you finish up your problem. What kind of fraction is this? This guy's improper. We have to convert it to a mixed number. And how do we do that? How do we go from an improper fraction to a mixed number? We're going to divide. So we'll do 12 into 289. 12 goes into 28 twice. Gives us 24. Subtract and get 4. Bring down your 9. And then 12 goes into 49 4 times to get 48. Subtract and get 1. And then remember how we put our answer together. That 1 becomes our numerator. We started with a denominator of 12, so we end with a denominator of 12. So our final answer is 24 and 1/12. And then we cannot reduce that because 1/12 is reduced as far as it will go. So we're done. That's our final answer. Let's look at another example. Go ahead and pause the video and try this one on your own. Convert 1 1/4 and 4 2/3 to improper fractions, and then multiply across the numerators times the numerators and the denominators times the denominators. And then start this video back up and we'll double check it together. So first step, 1 1/4, 4 2/3, we have to make these into improper fractions. So 4 times 1 is 4, plus 1 is 5. So 5/4 times, and then over here we have 3 times 4, which is 12, and then 12 plus 2, which is 14/3. So now we'll multiply. 4 times 3 is 12. 14 times 5, 4 times 5 is 20, carry our 2. 5 times 1 is 5, plus 2 is 7. So that'll give us 70. And now that we finished our multiplication, this is improper. So we need to convert that improper fraction to a mixed number. And remember, we do that by dividing the denominator into the numerator. So 12 will go into 70 5 times. 5 times 12 is 60. Subtract and get 10. 5 is our whole number. The 10 becomes our numerator. We started with a denominator of 12, so we're going to end with a denominator of 12. So we have 5 and 10 twelfths. So that's our first question we need to ask. The next question we need to ask is, can we reduce our answer? So can we reduce 10/12? Is there any number that will go into both 10 and 12? And there is. We can divide both of these numbers by 2. To get 10 divided by 2 is 5, and 12 divided by 2 is 6. So our final answer for our multiplication is 5 and 5/6. How about this one? 2 times 4 and 7/8. Now we have a whole number. We don't have any fraction. So again, pause the video, give this a try, and see what you come up with, and then we'll take a look together. So 2 things going on here. First, how do we write a whole number as a fraction? What do? We put it over 1. So 2 is the same as 2/1. This is how we write 2 as a fraction. And then this guy here is mixed, has to become improper. So we will do that with our little windmill. 4 times 8, which is 32. 32 plus 7, which is 39/8, and 2/1, and then multiply. So 1 times 8 equals 8. 39 times 2, 9 times 2 is 18, carry your 1. 2 times 3 is 6, plus 1 is 7. So we'll have 78. So 2 times 39/8 is 78/8. But then again, what kind of answer did we get? What kind of fraction? Our fraction is improper. We need to turn it into a mixed number before we enter it in Blackboard so we can get full credit. So how do we go from an improper fraction to a mixed number? We divide. 8 on the outside, 78 on the inside. How many times will 8 go into 78? It goes in 9 times. 9 times 8 is 72. Subtract and get 6. And then remember how we build our answer. The remainder becomes our numerator. We started with a denominator of 8. So we end with a denominator of 8. So we have 9 and 6/8. So that's part 1 of finishing our answer. Part 2. Can we reduce 6/8? Yes, if we divide 6/8 by 2, because those are both even numbers. We should get 9 and 6 divided by 2 is 3, and 8 divided by 2 is 4. So 9 and 3/4. So now that we've done multiplication, let's take a look at division, because what we will see here in division is incredibly similar to multiplication, just with one twist. We start with our first big rule, which was the same for multiplication, is that any mixed numbers have to become improper fractions. You cannot divide or multiply with a mixed number. So that has to be step 1. And then after that, we have this little guy here, kind of like a mnemonic, to remember how we work through our division problem, copy dot flop. So here's our division problem, 1/4 divided by 5/9. So what does copy dot flop mean? Well, copy, step 1, means we're going to copy down the first fraction. So we copied down 1/4. Dot, step 2, means we're going to turn our division into a multiplication sign, which can commonly be written as a dot. And then flop, or step 3 here, you're going to take your last fraction and turn him upside down on his head. So that's where we went from 5/9 to 9/5. After that, you're just going to multiply this like it was one of the multiplication problems we just looked at. So 1 times 9 is 9, 4 times 5 is 20, so our final answer here is 9/20. And that's why I said it's basically multiplication with a twist. The twist is that your second fraction gets flipped upside down on its head. Now, just like with multiplication, this is equally important to our first step. Make sure that you finish your answer. If your answer is improper, it needs to be converted into a mixed number. If your answer can be reduced, it needs to be reduced. So let's take a quick look at our answer here, 9/20. Is it improper? First question you should ask, and it's not improper. The top number is smaller than the bottom. Can we reduce it at all? Is there anything that will go into both 9 and 20? And the answer to that is also no. We cannot reduce 9/20, so we are done with that problem. Okay, let's take a look at a few examples. This first one here is 5 1/3 divided by 2 3/4. So first step, can we divide with mixed numbers? The answer to that is no. So we have to convert our mixed numbers into improper fractions. The very first thing we have to do. Okay, so let's do that. So we'll start with 5 1/3. So if you remember from the first fractions lecture, to go from a mixed number to an improper fraction, we do the denominator times the numerator. So we'll do denominator times whole number, 3 times 5, and then add the numerator plus 1 all over our denominator. 3 times 5 is 15, 15 plus 1 is 16, so we get 16/3. Okay, next one, let's do 2 3/4. So denominator times whole number, 4 times 2, plus numerator, plus 3, all over the denominator. 4 times 2 is 8, 8 plus 3 is 11, and keep our denominator, so 11/4. Okay, now that we have our two mixed numbers converted to improper fractions, let's set them in our problem and go from there. So 5 1/3 we converted to 16/3. And then we're going to divide that by, don't flip anything yet until you have your problem set up with your converted fractions. Divide that by 11/4. All right, so copy dot flop. First fraction stays the same, 16/3. And then dot, we're going to turn our division into a multiplication. And then flop, the second fraction, we flop him upside down on his head. So now instead of 11/4, we have 4/11. Now we can multiply, just like it was a regular multiplication problem. So we start with 16 times 4, which is 64. And then 3 times 11 is 33. Now, we're not done yet. Remember our two big questions that we need to ask after we finish any math problem, any fractions problem. First question, is our answer proper or improper? And this fraction is definitely improper because the top is bigger than the bottom. So we have to convert our improper fraction to a mixed number, and remember we do that by dividing. So denominator on the outside of our division box, numerator on the inside of our division box, and 33 goes into 64 one time. 1 times 33 is 33. Subtract and get 4 minus 1, 3 is 1, 6 minus 3 is 3. So subtract and get 33, or 31, sorry. That 31, remember, will become our new numerator. And then we started with a denominator of 33, so we'll end with a denominator of 33. So now we have 1 and 31 over 33. Can we reduce 31 over 33 by anything? And the answer to that is no. There's nothing that will go into 31 and 33. 31 is prime. So our final answer, once we finish everything, and once we make our final answer number look pretty, our final answer is 1 and 31 over 33. Let's do another example. Here we have 7 over 8 divided by 8 over 7. So we don't have to convert these, that's nice. Let's do our copy dot flop. So first fraction, 7 over 8, will stay the same. Division turns to multiplication. Second fraction gets flopped upside down on his head. So now instead of 8 over 7, we have 7 over 8. Multiply like you would a normal fraction. 7 times 7 is 49. 8 times 8 is 64. So ask your two big questions at the end of your problem. Is it proper or improper? And this one is a proper fraction. So we don't have to divide. Next question, can we reduce? And no, we cannot. There's nothing that will go into 49 and 64. So this right here is our final answer, 49/64. One more. Here we have 25 over 24 divided by 15 over 36. There are two ways that you can do this problem. One is you can just jump right into it and do copy dot flop and do 25 over 24 times 36 over 15. That's perfectly fine. It will get you kind of a big number. You'll get 25 times 36, which is 900. And then 15 times 24, which is 360. And then you can reduce from there. Both of those can be divided by 30. 360 divided by 30 will give us 12. 900 divided by 30 will give us 30. And then we can divide both of those again by 3. 30 divided by 3 is 10. 12 divided by 3 is 4. And then divide one more time by 2 to get 5 over 2. And then because this is improper, we'll do 2 into 5. 2 goes into 5 twice, which gives us 4. Subtracting it 1, so we get 2 1/2. So that's one way that we could do this problem. And that's perfectly fine. There's nothing wrong with doing that way. The other way that we could do this problem would be to start by reducing that 15 over 36 and making it a little bit smaller. So 15 over 36, we can divide that by 3. 3 goes into 15. 3 goes into 36. 15 divided by 3 is 5. 36 divided by 3 is 12. Remember, we haven't changed the value of our fraction. We've just changed the size of the number by which it's written. So we can substitute that in instead and do 25 24ths divided by 5/12ths, which will give us 25 over 24 if we do our copy dot flop 12 over 5. And then this will give us just a smaller fraction to have to work with after we multiply. So 25 times 12 is 300. And then 5 times 24 is 120. So we kind of skipped a lot of our reducing that we have up here. Now we're still going to have to reduce. Again, we can divide both of these by 30. 300 divided by 30 will give us 10. And then 120 divided by 30 will give us 4. And then we can divide that by 2 to get 5 over 2. And then divide, just like we did in the previous problem, to get 2 and 1/2. So either way is acceptable there, and I wanted to show you that problem to show you that you can reduce what's up here before you start doing your copy dot flop. You can do this for multiplication too. You can reduce those fractions and make them smaller so that you have something that's a little less unwieldy to work with, right? We skipped a lot of reducing when we reduced our fraction at the beginning. So now that we've covered multiplication and division, let's get into adding and subtracting with fractions, which I think is the more complicated of our 4 functions, mostly because we have to have common denominators. So for adding and subtracting, we don't need to convert mixed numbers to improper fractions. That was kind of our big guiding rule for multiplying and dividing with fractions. For adding and subtracting, we can keep our mixed numbers mixed numbers. The big rule that now guides us here is they gotta have the same denominator. Right? You cannot add fractions together that don't have the same denominator. Now, let's look at what we have when we do have fractions with the same denominator, and then we can go and take a look at what happens when we don't. So, for example, we have right here 3/5 plus 1/5 equals 4/5. So to add or subtract, you'll simply add the numerators together. So 3 plus 1 equals 4. And then you just carry the denominator straight over. It's the same if you were subtracting. If we had 3/5 minus 1/5, we do 3 minus 1 is 2. And just you keep the same denominator. That's it. If this was mixed numbers, if we had 2 and 3/5 plus 4 and 1/5, you just add your whole numbers. 2 plus 4 is 6. And then add your fractions. 3/5 plus 1/5 is 4/5. Pretty straightforward, no? Especially when all of our fractions are the same denominator. Now the same rule holds true for adding and subtracting as it did for multiplying and dividing, in that you want to make sure that you reduce your answer. That problem has to be reduced down to its lowest fraction in order for you to get credit for it on your homework. And also, it's good practice. Okay, let's take a look at what happens when we don't have the same denominator. A lot of the time, my students get fractions that have 2 different denominators. They kind of freak out, and I get this. Well, 1 plus 2 is 3, 4 plus 3 is 7, 3/7, done. You can't do that, sadly. You cannot add your 2 denominators together. You should never be adding them or subtracting your denominators. What we need, instead of adding or subtracting our denominators, is we need to find a common denominator. And we need to convert 1/4 and 2/3 into equivalent fractions, equal fractions that have the same denominator. So there are a few ways that we can think about this. Think back to the equivalent fractions lecture from earlier this week. One is we can list multiples of 4 and 3 and see what they share in common. That'd be a good place to start. So remember, a multiple is the times table of a number. So the multiples of 4. Well, 4, 8, 12, 16, 20, 24, 28. We could keep going in theory. Let's look at 3. 3, 6, 9, 12, 15, 18, 21, 24, 27. And again, that will keep going as well. Okay. So what do we have in common for 4 and 3? What multiple do they both share? Well, they both share 12. They also both share 24. So we could convert 1/4 and 2/3 in theory. We could convert these both into equivalent fractions that have either a denominator of 12 or a denominator of 24. So we have two options. Which one do we want to pick? Ideally, we want to pick the smaller number, because this is going to give us a lot less work later on. We will not have to reduce as much. So 12 is our fraction of choice. Now that's one way to think about how to find your common denominator. Another way to do it, and I have posted for you a times table in Blackboard that goes up to the 12's place. Another way to do it would be to use that times table. So this guy right here. So we have a fraction with a denominator of 3. We have a fraction with a denominator of 4. Just stick your finger on each of those rows for your times table and see where they intersect. So here's 3. Here's 4. Where do they meet? Right there. Okay, let's use 12. So either of those ways would be acceptable. I've said it many, many times, and I will continue to say it. If you know your multiplication tables, this part of math will become breathtakingly easier than if you are not familiar with your times tables. So try and spend, at least 5 or 10 minutes a day working on your multiplication tables, especially the stuff higher than 5, like your 6 and 7 and 8 and 9 times tables. That will be so useful right now. So whatever way we choose, we know that we want to make both of these fractions into equivalent fractions. And equivalent fractions with a denominator of 12. All right, let's do that. So 1/4. How would we write 1/4 as a fraction with a denominator of 12? 4 times what equals 12? Well, 4 times 3 equals 12. And remember, whatever you do to the bottom of a fraction, you always have to do to the top. So 4 times 3 equals 12. We'll do 1 times 3 to get 3/12. The same thing with our 2/3. We have 2/3. We want to write it as an equivalent fraction with a denominator of 12. We know that 3 times 4 equals 12. So we'll multiply the whole fraction, top and bottom, by 4 to get 8/12. Now that we have our two new equivalent fractions, let's rewrite our problem and go from there. So 1/4 converted to 3/12. 8/12, or 2/3 converted to 8/12. Let's add. 3 plus 8 is 11. Carry the denominator over. So our answer is 11/12. Let's look at another example. We have 5/7 and 1/3. We cannot add these together. You can't add them and get a denominator of 10. So let's look at our multiplication table for each, our multiples for 7 and 3. For 3, our times table is 3, 6, 9, 12, 15, 18, 21. For 7, we have 7, 14, 21, 28, 35, etc. So what do both 21 or both 3 and 7 have in common? They both have 21 in common. We can convert each of these fractions to an equivalent fraction with a denominator of 21. So let's do that. 5/7, and we want to write it as a fraction with 21 as a denominator. What will we do? 7 times 3. Multiply top and bottom. So we get 15 over 21. How about 1/3? 1/3, and we want an equivalent fraction with a denominator of 21. Well, we'll multiply this whole thing top and bottom by 7. 33 times 7 is 21. 1 times 7 is 7. So now we can rewrite our problem with our two equivalent fractions. So 15 over 21 for 5/7 plus 7 over 21 for our 1/3. And then go ahead and add. Carry your denominator, never add or subtract your denominator. And then 15 plus 7 should give us 22. So now that we're done with our adding, let's ask our two questions. First, is this answer improper? That is the first question you should always ask yourself when you finish any fractions problem. Is your answer improper? And in this case, yes, it is. Our numerator is bigger than our denominator. So we have to divide denominator on the outside, numerator on the inside. 21 goes into 22 once. 22 minus 21 will give us 1. Remember that our remainder becomes our new numerator, and we started with a denominator of 21, so we'll end with a denominator of 21. So our final answer is 1 and 1/21. And then, of course, your second question should be, can I reduce that answer? And no, you cannot reduce 1 over 21. That's as small as it gets. So we're done. Next problem. Go ahead and pause the video. Try this one on your own. And then when you're done, come back and we will go through it together. So here we have 5 and 2/3 minus 3 and 1/5. We have mixed numbers, we're doing subtraction, and again, we have two fractions whose denominators are different. So we need to find a common multiple that both 3 and 5 share in common. One way to do this, aside from listing multiples out in the corner of the slide, would be to simply multiply your denominators together. And that will tell you what your equivalent fraction denominator can be. 3 times 5 equals 15. So we can convert both of these fractions to equivalent fractions with a denominator of 15. So let's do that. 2/3 to a denominator of 15. We multiply 3 by 5. So we'll multiply the 2 by 5 as well to get 10. And then 1/5 to a denominator of 15. We'll multiply 5 times 3, and we'll do 1 times 3 as well to get 3 over 15. Now that we have our two new equivalent fractions, let's substitute them into our problem. So now we have 5, 2/3 we converted to 10/15 minus 3. Our 1/5 we converted to 3/15. Go ahead and subtract. 5 minus 3 is 2. 10/15 minus 3/15 is 7/15. Ask your two big questions. Is our fraction improper? 7/15. No, it is not. Can we reduce it at all? Is there anything that goes into both 7 and 15. And the answer to that is also no. This is the end of the line. We're done. Last example, another mixed number. Here we have 10 and 3/4 plus 5 and 1/8. Again, take a minute and pause this and try this problem on your own, and then come back and let's take a look at it. So 3/4, 1/8. There are a couple of things that we could do here by way of finding a common denominator. One, we can multiply 4 times 8 and get 32. And then we can use that as our common denominator. So let's take a look at that right here. So we have 3/4. We want an equivalent fraction with a denominator of 32. We know 4 times 8 equals 32. So we'll multiply the top of our fraction as well by 8 to get 24. And then we have 1/8 that we want as a fraction, an equivalent fraction with a denominator of 32. So let's multiply by 4. Top and bottom to get 4 32nds. Okay, now let's substitute in our two equivalent fractions and rewrite our problem. So 10, our 3/4 became 24 over 32 plus 5, and then our 1/8 we converted to 4 over 32. And now we add. 10 plus 5 is 15. 24 plus 4 is 28. Keep your denominator, and we're done. Now, our two big questions, is this fraction improper? 28 over 32. It's not improper. Can we reduce it? Yes, we can reduce 28 over 32. And we know that we can divide this by 2 because 28 and 32 are both even. They both end in an even number. So let's divide 28 and 32, both of them by 2. 28 divided by 2 will give us 14, and then 32 divided by 2 will give us 16. Are we done? Or can we reduce it again? We can reduce it again. We can divide by 2 again. 2 over 2 to get 14 divided by 2 is 7, 16 divided by 2 is 8. Okay, how about 7 over 8? Can we reduce that? And the answer there is no. So our final answer, don't forget your 15, is 15 and 7/8. Once we reduce 28 over 32 down as far as it will go. I want to look at two other ways that we could do this problem. Besides just multiplying 4 times 8 and getting 32 and using that to convert to our equivalent fraction. One other way would be to list out your multiples for both 4 and 8. So for 4 we get 4, 8, 12, 16. For 8 we get 8, 16, 24. And if you are familiar with your times tables, probably the first thing you thought of for both 8 and 4 was 16. I know probably some of you are going, wait, what about the 8? We're going to look at that next. So let's take a look at 16 instead of 32. And this is, we're going to get the same answer. This is just showing you different equivalent fractions that we could use for this problem. So 3/4, let's convert it to an equivalent fraction with a denominator of 16. How do we go from 4 to 16? Well, we multiply by 4. So we'll multiply our whole fraction, top and bottom, by 4. 3 times 4 is 12. So we get 12/16. How about 1/8? How do we write that as an equivalent fraction with a denominator of 16? We multiply that by 2, top and bottom, to get 2 over 16. So now substitute our equivalent fractions in. We get 10 and 12/16 plus 5 and 2/16. And we'll get 10 plus 5 is 15. 12 plus 2 is 14 over 16. And then ask your big question, can we reduce our answer? And of course the answer here is yes, we can reduce that. 14 over 16 we can divide by 2. 2 over 2, 14 divided by 2 is 7, 16 divided by 2 is 8, so our final answer is 15 and 7/8. So that's another way we could do this problem, and that's just showing the difference between a very large common denominator, like we had with the 32, versus a smaller common denominator, like we had with the 16. You'll notice we got the same answer, which is what you would expect. We just had less reducing to do when we finished the problem. Okay, now let's look at that 8, because probably you noticed that in our list of multiples, right? For both 4 and for 8, 8 is a multiple. And this is another way that we could do this problem. So this is fraction addition 3 different ways. We can convert our 3/4 to something with a denominator of 8. And if we do that, do we have to do anything with our 1/8? No, we can just convert our 3/4 to an equivalent fraction with 8, and then we can leave this guy here just as he is. And that's perfectly fine. You do not, and you will not always have to convert both fractions in a problem. The goal here is finding a common denominator, not necessarily converting both your fractions. So let's turn our 3/4 into an equivalent fraction with a denominator of 8. 4 times 2 equals 8. Multiply by 2 top and bottom, 3 times 2 is 6. And now let's substitute that in for 3/4. So 10 and 6/8 plus 5 and 1/8. And add. 10 plus 5 is 15. 6 plus 1 is 7. We get 15 and 7/8. So those are 3 different ways of looking at doing the same problem. One where we multiplied our 2 denominators together, one where we listed out different multiples, and one where we only converted 1/2 of our problem, half of our fractions. And you see in all of these, we got the same answer. Because again, the technique is all about making sure you have the same denominator, not necessarily that you converted both of your fractions. So thank you for hanging in there with me. I know that fractions, functions can be very complicated. There are a lot of steps that you need to commit to memory. If you have any questions about anything that we went over, please go ahead and shoot me an email or drop by office hours. I would love to see you. And if not, good luck on your homework and best of luck on the quiz.